So in this video, I want to start talking about section 10.5, which is all about what are called conic sections. In conic sections, so we get the name by, if you think about a cone, and so here I have a one cone stacked on top of another cone, and then you're going to take a plane, so just a sheet of paper or just any flat two-dimensional thing, and you intersect the cone, you get certain shapes, and these are all familiar shapes or shapes of things that you've seen before. So for example, if you were to take a cone and cut it straight across, you get a circle. Okay, so if you were to think about the intersection of that plane in the cone, you get a circle. If it's at a slight angle, you get an ellipse. You get kind of this oval shaped curve here. And if this goes through, so if this is at the right angle, so it only goes through, say, the bottom half or the top half of the cone, you get a parabola. And if it goes through both parts of the cone, you get a hyperbola. And so these are all the different shapes that you can make if you intersect a cone with a plane, okay, a flat two-dimensional plane. This is also the shapes that you get if you were to take a flashlight and shine it on a light, shine your light on a wall. Say if you were to shine it straight on, you would get a circle. If you were to do a slight angle, you get an ellipse. You can do parabolas, and hyperbolas are a little harder there because you only get the one direction with the flashlight, but that's the idea. So these are conic sections, and we're going to study each of these. These have different interesting properties in each case. And let's just right away get over the circles. There's not much to talk about. I'm just going to kind of say everything that we need to. Basically, I can just come right out and say everything that we need to about circles and just be done. So circles are kind of the most boring of these objects because they're the they're the most common. We work with them a lot. There's not too many surprises here. But if you were to take x minus x naught plus y minus y naught, so x minus x naught squared plus y minus y naught squared equals r squared. This is a circle with center x naught y naught and radius r. And there's not really too much more that we need to talk about here. I mean, that's kind of the general formula. Here I have x naught y naught. We're going to pick some value of r, and then all the points that are the same distance away from that center, that's going to be that circle. Okay, so something like that. And so this value here that we picked, the radius is r. Okay, so it's all the points that are some common fixed distance away from the center. And that's really all there is to talk about with circles. Yeah, I can't really think of anything else that I want to say there. The next thing to talk about is ellipses. And so ellipses are going to have, generally, they're going to have the following. They're going to look like x squared over a squared plus y squared over b squared equals 1. Okay, and there's a few different things that are going to happen here. So when I think of ellipses, there's not really too much mystery here. Let's just look at an example. Let's say we were to look at x squared over 4 plus y squared over 9. Okay, something like this. And here, if y is equal to 0, then x squared is going to be equal to 4. So x is plus or minus 2. And so we have the points plus or minus 2, 0. And likewise, if x is equal to 0, we get y is plus or minus 3. These kind of outer points here are specifically referred to as the vertices. Okay, and so here, if we were to graph this ellipse, what we would end up with would be, so we're going to have an ellipse that's going to move 2 units in the x direction, 3 units in the y direction, and then it'll look something like that. It's snapped into a circle here. Let's make it a little bit more ovally. Okay, something like that. The drawing tool was making, it thought I was drawing a circle. And so that's the ellipse. So just a few things to talk about with ellipses. The longer part of the ellipse, so in this case, this stretches out along the y-axis more than it stretches out along the x-axis. And so we call the y-axis the major axis. Okay, so the major axis in this case is the y-axis. So when we say the major axis, we're specifically referring to the axis on which the points are further from the origin, or further from the center of the ellipse. And when I talk about the center of the ellipse, actually, I shouldn't talk about the center. I should talk about what are called the focal points, or the foci, or foci. I say foci though, because it's a focus, foci. And so the focal points are the values. In this case, they're going to be, the focal points are always on the major axis. So in this case, they're going to be on the y-axis. And so they're going to be the points 0, c, and 0 minus c, where c squared is going to be the larger value minus the smaller value here. So 9 minus 4. So c squared is going to be 5. And so that means c is going to be plus or minus the square root of 5. So it's like 2.5. So our focal points are going to be something like here and here. And it turns out what an ellipse is if you were to compute the distance between these two focal points and every point on the ellipse, you get a constant. And so if you were to add up that total pink line, so the two purple lines added up, it doesn't matter what point you look at. So you could look over here. That will give you the same value. You could pick another point that's maybe here. Okay, and if you were to add up the purple line segments and the red line segments and the green line segments, those would all be the same length. So the defining property of an ellipse is that the sum of the distances between the focal points and the points on the ellipse is a constant. Okay, so the sum of the values is a constant. Okay, and so here our focal points are, so for this particular parabola, the focal points are 0 plus or minus square root of 5. So those are the focal points of the foci. Okay, and so that I think is everything I wanted to say about ellipses. If the denominator for the x squared term is larger than the denominator for the y squared term, things get shifted. So there's not too much to say there. So if we were to look at, say, x squared, I want green, I want blue, but if we were to look at, so let's say we were to look at x squared over 10 plus y squared over 3 equals 1, then what would happen is that our x values would go from negative square root of 10 to square root of 10. And our y values would go from negative square root of 3 to square root of 3. So square root of 3 is something like 1.7. And then square root of 10 is something like 3 and a little bit, 3.1. So something like that. These don't need to be too precise here. And so that is going to give us an ellipse. Hopefully the drawing tool will like this ellipse a little better. Okay, and so that's our ellipse. And the focal points are going to be given by, in this case, plus or minus c0. So the major axis is the x-axis because that's the axis where the points are spread out the most. And we're going to get plus or minus c comma 0, where c squared is 10 minus 3 or 7. Okay, so c is plus or minus square root of 7, and therefore the focal points are plus or minus square root of 7 comma 0. Okay, and so square root of 7 is 2 and a little bit. So something like that. Okay, so those are the focal points. Just two more things that I want to say here, or just a few more things I should say about the ellipse, is that sometimes I think it's nice to actually see a physical representation of how this is drawn. So I have a video of that I wanted to just show you. This is I kind of mentioned this video last time, but this is the why planetary orbits are ellipses. I'm not going to go through the whole video, but I just wanted to show you the presenter here takes two pins and then puts a string around it. And then you can, if you can think about the curve that you get by keeping this string completely taut, that's an ellipse. Okay, and so that's kind of the physical representation of the ellipse. And so he says it's similar to how you would draw a circle where all the points are kind of a fixed distance away from there. Okay, so I think that that's nice to see. The other thing I wanted to mention is that this is specifically called the focus because this has to do with the Latin word for fireplace. And the place where foci come up here, or where focal points and ellipses come up, is exactly in planetary orbits. And it turns out that the Earth rotates around the sun on an ellipse. And one of the focal points of this ellipse is the sun, the fireplace. Okay, so the focal points are called that because of the astronomical phenomena. So the Earth orbiting the sun in an ellipse. Okay, so I think that's everything I wanted to say about ellipses. So what I'm going to do is I'm going to kind of split up this video into a few pieces. In the next piece, we'll talk about parabolas and hyperbolas.